This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we'll be doing another example of displacement time graphs. So here is the example. Let's just get started with it. So the question says the position time graph. So we know this is a displacement. So here is the position time graph. Below represents the motion of two students. Mac in red. This is Mac. So we can just label this guy here. This is Mac. And this is Tosh in blue, the one in blue, as they enter and exit the school library during a passage period. So one of them enters and one of them exits. So we can assume Mac is entering the library, he is entering the library, and Tosh is exiting the library. Okay. So use the graph to determine the speeds at which two students move. Okay, so this is a position time graph, and the question says use the graph to determine the speeds at which the two students move. So let's see here. Let me just increase the brightness. So let's see here. Let me change the color. Okay, so first of all, let's see. We have to find the speed at which both of them move. So first, finding the speed of Mac. So we can see from here that since this is a position time graph and he has a position here which is fixed, he has a constant position, a constant displacement, as in he's just standing. This is the origin of the graph and he's just standing here at this point for the first second. So during this period he is stationary. During this period, since the position is not changing. However, here the position is changing and we have a gradient. So you remember from the previous lectures that a gradient of the position time graph gives us speed. So we always know when there is a horizontal line, the gradient is 0, and so the speed is 0 here. Here we have a gradient, and we can predict just by looking at it that it will have a negative gradient. So you will always have to see whether it's a negative gradient or a positive gradient, and so you can just in such cases you can just tell yourself from beforehand that if it's a negative gradient, it means the student is coming to O, and if it's a positive gradient, the student will be moving towards O, because always remember these two will mean opposite things. If this means coming towards O, then this will mean going away from O. So here we know it's a negative gradient because the line is going from top to the bottom. Let's just find out the gradient. Let's see if I'm right or wrong. So the first point is 1 and 12. The second point on the line is 4 and 0. And since this is a straight line, the gradient will be same throughout the line. The slope will be same throughout the line. So anyway, let's find the gradient. The gradient is y2 minus y1, 12 minus 0, divided by x2 minus x1, which is 1 minus 4. So 12 minus 0 is 12, and 1 minus 4 is minus 3. So 12 over minus 3. The gradient is minus 4. This means that he has a velocity of minus 4 meters per second. The minus 4 only shows, as we have described earlier, that a minus sign will mean he's coming towards O. The 4 is the magnitude. 4 meters per second is the magnitude. So he's coming with a velocity of 4 meters per second towards O. Let's see the velocity of Tosh. Let's change the color here. Okay, so let's find the gradient for Tosh again. So m is equals to delta y over delta x again. Let's see 2 points, 0 and 2. This is my first point, this one, and this will be my second point. I can take any 2 points on the line. I can take this one and I can take this one, but since I know the y's and x of both of these 2 points, this will be simpler. Any 2 points will do and give the same gradient. You can try any of the 2 points. So here I'm using 4 and 12. This is my first point. and here I'm saying 0 and 2. I can say since the line is increasing, the gradient will be positive. Let's see. y2 minus y1, 12 minus 2 divided by 4 minus 0. This will give me 10 over 4, which is 2.5 meters per second. Or the gradient is 2.5, which means a velocity of 2.5 meters per second. And this one, but since it's a positive 2.5 meters per second, this means it's going away from O. The positive sign denotes the direction. So we know from the fact that this student is moving faster than this one, irrespective of the direction. So then the question says, then determine how much faster the fastest student moves than the slower student. So since this is 4 meters per second, we'll ignore the direction since we are talking about speeds here. So we'll just simply ignore the direction. Speeds are irrespective of direction. So we will say, since he is moving at 2.5 meters per second and he is moving at 4 meters per second in the opposite direction, the faster student is moving 4 minus 2.5 meters per second, 1.5 meters per second. He is moving 1.5 meters per second faster. As in, Tosh is moving. Oh, okay. I think we found Tosh first. Yeah, so Tosh is moving. This is Tosh. The one in blue was Tosh. So Tosh is moving faster than Mac. I think I said Mac earlier when we were. I think I said Tosh earlier when we were calculating the velocity for Mac. So does this clear the confusion? Tosh is moving 1.5 meters per second faster than Mac. So this is again one more example of calculating velocity from a position time graph. So I hope you understood this. Next in line is the velocity time graph. So stay tuned.